Hello everyone, welcome to my channel. This is Dipesh. We are talking today for another fun-filled session. Today the week, Sunday, so we are trying to explore things on OpenTelemetry. People have generally asked you are doing all the practical related use cases, but today we will talk about the OpenTelemetry basic concepts. What is OpenTelemetry? What is Otel for a beginner, so that he can understand how we use OpenTelemetry in an industry use case, and it can be used with any of your monitoring tools. So, let's get started. It will be a fun-filled session. We'll be doing some kind of, examples at the end of the session. But first of all, we'll understand what is an OpenTelemetry, a very buzzword which is being, getting popular day by day, and it is being used by so many companies now. You talk about Fortune 500 companies, or Fortune 100 companies like Apple, Microsoft. Everyone is using now open telemetry just to save the license cost and to the vendor agnostic work. So let's understand what is open telemetry right from scratch. Anybody who wants to learn can simply watch this video. It will be, a purely a conceptual session, and then at the later point of time, we'll see some kind of, practical use cases, how to use open telemetry and do the monitoring of your infrastructure and applications on any cluster, whether Ubuntu or a Kubernetes-based cluster. So let's get started. And if you have not like and subscribe the channel, please do that so that you can get a lot of other beautiful scenarios pertaining to OpenTelemetry and Grafana. So we have created a GitHub page for the same. What we'll be doing in this session. So you can follow this GitHub page. I'll be posting it into the description of this video. And then let's see what are we gonna do in this. Let's go back to the VS Code, or for that matter. First of all, what is an Otel? An Otel, Open Telemetry is first of all not a technology. It's not a tool. It's a framework, or you can say it's a toolkit that can be used to collect your data, telemetry data, and send that to your receiving end. So it can be any receiver. It can be Prometheus, Grafana, and blah blah. So many other tools. But that is why it is called as vendor neutral open source observability framework, right? Vendor neutral. So it is not depending on vendor. So today, suppose you're using App Dynamics as a monitoring tool. Tomorrow you want to use something else. But Open Telemetry will remain as a framework to use with any other observability tool. Now, why it is so popular? Because it is being supported by 40 plus observability vendors, and it has integration of so many libraries, like library like a Java, .NET, Golang, Python, and it is being adopted by numerous users. That was a quick overview. What is OpenTelemetry? Again, as I said, it's a framework or a toolkit that is designed to create and manage your telemetry data, like traces, the matrices, and important logs for your application, for infrastructure. Why it is called as vendor and tool agnostic? Because it can be used with any broad variety of observability backends, including open source like Jaeger and Prometheus. So it supports both. Uh, you know, it supports Jaeger, Prometheus. It supports your license tool called as Elasticsearch also. And moving on, it focuses on a generation of collection, management, and of telemetry data. And the major goal of telemetry is to instrument your application. And I say instrument, people used to say instrument your application, meaning you want to get the red matrices of your application, like rate, error, duration of your matrices, or for that matter, the web vitals of your matrices or your application. You can easily get it with the help of OpenTelemetry. uh, no matter what is your language, infrastructure, or runtime environment. It can be Kubernetes, it can be non-Kubernetes, or it can be microservices or non-microservices. So it is not gonna matter in this open telemetry. What is observability? I think we've already talked about in my previous session. Observability is a ability to understand the state of your application, how it is behaving, your infrastructure, and all the software that are working uh, to make sure that they are up and running. Then why OpenTelemetry? Good question. Why OpenTelemetry? So, see, everyone wants to save money, right? If we really going for a proprietary tool called as App Dynamics and Dynatrace on Elasticsearch, and we are using their agent. Suppose after 2 years, there's a strategy change in the company. They want to move from App Dynamics to suppose Grafana Cloud. Then they have to deinstall the App Dynamics agents to for collect the data, and then they want to install Grafana Cloud agents. So just to remove all that stuff, we will be using OpenTelemetry agents to capture the data so that if you change the software or change the tool at the receiving end, it will not gonna impact, right? So let's see some before we get into the collector level detail. Let's see the some basic, you know, the GUI feature. So this is the same image that you get it from the OpenTelemetry documentation. Also, let's understand what we are trying to say. So we are saying it can be any microservices application. It can be API based application. These are left hand side is all applications. Now the applications will send their all the length and breadth data, the health of their application or any Kubernetes infrastructure data. So this is first point is the application related data. The second section is the infrastructure related data, and they are sending it to a single point of contact called as Otel collector. Now in this case, so what is going to replace? So suppose you are using App Dynamics, so it will be App Dynamics agent. So now we will not use App Dynamics, we'll use Otel collector agent, and right side would be your tool related database. Now, what this Otel collector will do, it will gather the data from your applications as well as from infrastructure, and it will do some kind of filtration processing, and then will send that data to your either to time series database or to any traces database or to any column stores or any S3 related. So let's see another photo. Okay, these are all important, architecture. So what we have explained, we are saying that there will be receiver section where it will receive the data. Okay, and it can receive the data from Prometheus. It can receive the data from any other. It's a push-pull mechanism. We'll talk about more about it. So receivers is the first section. Okay. Then we have second sections called as processor. What processor will do that it can filter your data. Suppose 100 matrices are coming, 100 columns are coming. You can filter and take only 20 columns so that you don't have you know cost of shipping those that much amount of data to your at the later point of time at the end. We have a processors, we have a extensions also just to do health check and storage extension. We have certain connectors, and it is not mandatory, but you can use connectors to connect between receivers and exporters. And then third and the final thing is the exporters, which will send the data to any particular exporter. OTLP exporter means it can be HTTP or HTTPS based, any endpoint. It can be Elasticsearch, it can be a Grafana Cloud, it can be Tempo, or it can be Jaeger, anything. And then you have Prometheus exporter for storing the matrices and Prometheus, and Zipkinos exporter and Jaeger exporter for storing the traces. So these are the basic three building block of OpenTelemetry. We'll see all these things in a greater detail. So just do hang on this video. We'll be checking all those things. This is another photo. Suppose you have OpenTelemetry agent 1 on the application side, B, and so suppose you have 10 OpenTelemetry agents. So all these agents will capture the data and will send the data to processors. See, as I explained, sometime back. So A, B, C until N will collect the data and then will send the data to matrices to Grafana Cloud. In this case, they are sending matrices to Grafana Cloud, traces to Lightstep, and logs to dataset. You can use any other data base also. So like for traces, you can use Jaeger, you can use Zipkin, you can use Tempo, and for logs, you can use Elasticsearch, you can use Locky, right? And you can send traces to Signos, you can send traces to Jaeger. So this is what the figure is explaining. So this is all about the explanation from figure perspective. Let's understand and see how we are doing and uh, the examples or the configuration perspective. Right, so this is the collector. So collector, what is collector? Collector is a vendor agnostic way to receive, process, and export the telemetry data. The OpenTelemetry collector offers a vendor agnostic implementation to removes into scalability support. You can see these are the different formats. Now this is what I want to give more time to explain. Now what are the different collectors configuration structure? Now we have talked about three things, okay? Receivers, processors, and exporters. So we'll understand the receivers first of all, and then before we go to processors. Now what is the receiver? Receivers collect the telemetry data from one or more sources, and they can be pull or push. Pull or push means I'll explain from a configuration. Then you can, when I say you, application can send data to a particular endpoint. Suppose I have a application who is generating HTTP matrices, then it will be going to a particular port number called as 4317. So that is a push mechanism. Or pull mechanism is, suppose there's a node exporter already running on the server, then receivers can pull the infrastructure matrices or data from that node export endpoint. So at one point in time, receiver is pulling. At one point, the application is pushing the data. So it is pull and push. So this is what is important to understand. And it may support one or more the data sources. Now, before you go to processors, let's understand what is the receivers configuration. What are the options that we have in receiver? So I have created a YAML file to understand what all receivers we have. Right, so this is the YAML snippet. So receivers is the first section, and we can have a fluent forward. Now, fluent forward is another. This is a push mechanism. When I say push, application can send the logs to this fluent forward uh, at a port number 806006. Now, you may ask, earlier I was using fluent bit and Fluent Bit as an agent to collect logs. But in this case, you don't need to install Fluent Bit separately. The Otel collector agent, the moment you install, it will expose the Fluent forward endpoint with 80006, and then application send the logs directly. Second receiver is host matrices. Now, host matrices means this Otel collector will capture all these matrices related to your infrastructure like CPU, disk, file system, load, memory, network, process and paging. So this is something similar to your node exporter for capturing the infrastructure matrix. But this is another way, host matrices and fluent forward. These are the two important receivers. Now, Jaeger. Jaeger is another important receiver. Receiver, when I say, and the moment you install this hotel collector agent, and a port, Jaeger port will be activated on port number 4317, and that will be a push mechanism. Why push? Because application can push the traces to Jaeger at port number 437. So this is again receiver. So Otel will receive it. Okay, I want to get the data. So Jaeger will receive the data at 4317. Another is Kafka. Kafka is another receiver. Open Census is another receiver from traces and matrices. Jaeger was traces. Okay. Then we have a OTLP. This is a generic OTLP receiver for everything. When I say everything, Jaeger was only for traces. Now OTLP is a more mature receiver which can get. I'll be showing this OTLP example in a while, which can get the all three matrix logs traces at once. At one time only, and it normally exposes two ports 4317 4318. So gRPC port is 4317, where application can send data, especially metrics, logs, and traces on a push mechanism. Again, this is a push mechanism. Okay, at OTLP port. Fine. And then there's another Prometheus. Now this is a pull mechanism. Why pull? Because this is a Prometheus receiver. I am saying, please scrape my hotel collector matrices from the localhost, because my hotel collector is running on 8888 port, and slash matrices will contain all the matrices. So this is the pull mechanism. The hotel collector will pull the matrices from this port number 8888 slash matrices, and it will be stored in a Prometheus. And last but not the least, we have a Zipkin. So you can see there are so many receivers from understanding perspective. Like and we'll see the complete configuration. But first of all, let's understand the concept. So these are the, so many receivers available. The most prominent one, you can get all the details, the other receivers from the uh, documentation, the OpenTelemetry documentation. Let's see what is the next. Next is, suppose we have received the data. I want to process the data. Process means I want to filter the data. I want to drop certain things. I want to rename some certain things. I want to recalculate the data. I want to add some additional columns. So processor is what, that is the second important stage. Receiver is receive the data. Second is process that data. Okay, before you send it to relevant data sources. So where is the processor's configuration file? This is the processor. Now in this processors, what I'm doing, resource attributes, I'm adding these certain additional columns. So I can add the columns like this, key and action. So key is the column name and it will be inserted, and then from which attribute it will get inserted. This is the one. Okay. I want to delete, this will get deleted. So this is the action. So I'm processing my data, right? And this is my sampling of data seed, and then this is the processing of your traces. So this is the span name to attribute. This is the rule from which attribute I want to do this, enable this rule on this db.svc column and operation, and then separate. So this is a normal processor. You can add a lot of. So we'll be checking the examples also. The processor is more about the processing of data, right? Now let's see what is the next. Next is exporter, the very, very important one. Exporter is the third and the final thing where I want to send this data. It can go to Grafana cloud, it can go to Elasticsearch, it can go to any of your local on-prem Grafana. So export, send the data to one or more backend. So yes, it can send data, same data to one to Grafana cloud, one to Elasticsearch. It can send data to multiple data sources at one, well, in single pipeline only, right? And let's see the exporter example or exporter configurations. So this is my exporter configurations. So all these configuration will be putting into the the GitHub. It is already there. So exporters is, yes, file path. I can export my data to as a file path as a JSON. I can export my data to the OTLP Jaeger endpoint. So what I'm saying, whatever data you have captured from receivers and processors, please send it to this Jaeger endpoint. This is my Jaeger database. Okay, send it to my Kafka endpoint. Send verbosity detailed means I am saying that please have my logs in a detail so that I can understand what is happening. I can send my data to Open Census is another open source tool for capturing the traces and matrices. So this is the next another exporter. This is another Otel call to. You can put any URL basically like generic URL for your company, and then you can send the data to that. You can send the traces and matrices on an OTLP HTTP endpoint. So these are different endpoints which you can choose. You can send directly to your Prometheus also for matrices. You can do a Prometheus remote write also, the way Grafana Cloud does, and you can send it directly your traces to traces zipin also. You can send data to your Elasticsearch also for logs. You can send data to Tempo via OTLP, right? You can send data to any other database or tool that you think about. So this is all about exporters, right? So we have, importantly, we have saw these three things, receivers, processors, and exporters. Connectors are just to connect to pipelines. This is not so important to understand. Let's skip it. And then extensions are important. If you really want to pass any API key, username and password, health check, all those things are under extension. So I have an extension configuration also. So I can do health check, you know, professional related methods and the Z pages. Now let's see. We have now this is a very very important section to understand. Now we have uh, as a receiver receiving the data, processor will process the data, exporter will export the data. Excuse me. And services section will create pipeline that will do all these three things. Okay. Services contains these three subsection: extension, pipelines, and telemetry. So let's see whether I have a services. Uh, mm, yes, I have a configuration. So services look like this: service pipeline. So I have two pipelines currently in this picture. I have a matrices pipeline. So what I'm saying, So matrices, it will receive the matrices from two data sources. Okay, open census and Prometheus. Now processor's batch means nothing will get processed. Whatever is coming, just send it as a batch. Exporter, again, it is going to two data sources, Prometheus and OpenCensus. Similarly, it goes for traces. Traces, it is receiving the data from OpenCensus at Jaeger. It is doing a batch limiting and it is doing some kind of memory limiter. And then finally, the exporter here is OpenCensus and the Zipkin. So data is received from Jaeger, but sending it to Zipkin as an exporter. So this is all about the concepts. What is open telemetry? Why we use it? Different things. But let's see from an example perspective. Then only you will understand how it works. So we'll do a small use case. We will install Prometheus. We'll install Grafana on a Minikube cluster as a local on-prem, and then we'll install the OpenTelemetry agent just to get uh, the bare minimum data, or we will install the node exporter also. Okay, so first of all let me install uh, or maybe the node exporter will come from as a part of this Prometheus community. So I have a uh, I'm into Otel namespace KGP. There's nothing in this, everything's empty, so I'll just uh, install this Prometheus Helm chart, which will install Prometheus as well as it will install the other okay, so I need to go to this location, cd open telemetry, and you can go there. Yeah, it is asking for a Prometheus.yaml file. Let me see what is there in this YAML file. It is a help chart. So how to show Prometheus YAML file? What do you have? Yeah. So I'm just enabling remote write. So this is pretty straightforward thing. So whatever installation I'm doing, I'm enabling the remote write so that it can receive the data from the remote write or any endpoint. Okay, now it will install and we'll see the kgp minus w. So it is, you can see it is installing and the Prometheus server, it is installing a Prometheus node exporter also, and it is installing Prometheus kubestate matrices also for capturing the infrastructure data. So I think this will do all your job. Next thing is I will install my Grafana just to visualize this. Okay, I will do install Grafana, and then it will install Grafana. So Grafana is also getting installed. Okay, and to get the password for Grafana, I need to run this kubectl secret uh, to get the secret of Grafana. Okay, now you can see my Prometheus and Grafana are up. Huh? KGP, all pods are running. Kget SVC, K port forward. I'm port forwarding Grafana so that I can integrate Grafana with Prometheus. Okay, so this is my Grafana. The username is admin, and the password is the one which I just now encrypted here. Okay, so I need to copy this password, right? So I'm able to log into Grafana. I'll just go ahead and add the data source as a Prometheus data source, and I'll just this is my Prometheus service, which I think. Okay, so let me just go back and then check the Prometheus service get. Yeah, Prometheus server is the Prometheus server service, which is running on port number 80. And then I'll do save and test. Yes, Prometheus is working fine. I've added the Prometheus service. Now I'll see what all matrices are coming. Default matrices. I've not installed any OpenTelemetry agent so far. Okay, so these are all default matrices that will come. In this. See, these are all. There's no OpenTelemetry related matrices that are coming. Okay, now Now we will install this OpenTelemetry agent. You see OpenTelemetry agents on Minikube cluster. Now we'll see what it is. Otel k8s config.yaml. So Otel k8s config.yaml is Otel k8s config.yaml. And this is the file. Now we'll see. This is the config map which we are creating. Now, the config map, we will pass all the receivers. So I'll explain all these things again. So receivers, we are using an OTLP receiver, which is a push mechanism where if application is sending any data to it will send to 4317 and 4318 at gRPC code. Now we'll be using this section, which is a pull mechanism. So we have a Prometheus that will receive the data from Otel node exporter. Let me see the node exporter cluster IP. This is a cluster IP. So this is the pull mechanism. It will pull the matrices of node exporter and the CubeSat matrix from this cluster IP with on this port. Let me show you what I'm trying to say. So K port forward service. So this is the node exporter, right? Node exporter 9100. 9100. Okay. So node exporter is exporting all the matrices on this port. So these matrices will be pulled. Okay. It is a push and pull mechanism. So these matrices will be pulled by OpenTelemetry agent and it will be get processed. So this is the next section. Process is batch and memory limited. That's the default section. Since I'm not using anything on the health, so the extensions are empty. Now this is the exporter. So I'm saying please receive the Prometheus data and then send that Prometheus data to this Prometheus remote write, which is nothing but is my the Prometheus service endpoint with API v1 write, which I have enabled the remote write. So this is exporter section. This is the processor section. This is the receiver section. And then let's see the services section. Services, I have extensions, the pages, that's okay. Now this is the pipeline. So I've created two pipelines. However, I'll be using only matrix pipeline in this section because I do not have anything installed for traces. So this will be ignored. So matrices pipeline, it will receive the data from Prometheus. It will receive the data from Prometheus as a pull mechanisms. It will pull the node exporter and the CubeSat matrices data or matrices. It will process as a batch. Whatever is coming, it will go and will send the data to Prometheus remote write. So that is what is going to happen in this. So I've stored all this configuration in this config map, which I'll be using in the deployment. Now next is I have a service of OpenTelemetry collector, which will expose my these ports for getting the data in case. And this is the Otel collector matrices that will expose on 8888. This is the deployment where it's using this config map. This is the image I am using. Where's the image? Yeah, the Otel collector latest image. Okay. Perfect. So I'll now go back to my documentation and now install the clue OpenTelemetry collector, agent. Now the Otel collector agent have been installed. Let's see the KGP. Yeah, the Otel collector agent is running. Now let's go back to my Grafana. I'll just refresh. Now I should get some data from the node exporter as well as from the cube state matrices. That is something I want to see. See, now I'm getting this. The same job, Hotel cube state matrices, which we configured here. Okay. So that you can, these two jobs are not coming earlier, right? So node exporter, Hotel cube state matrix, Hotel node exporter, cube state matrix. So these matrices are started coming on, flow. Let me check it with the help of dashboard because I don't agree. Let me go back. I will import one dashboard, the node exporter dashboard 1860 load. Yeah, the node exporter data is coming, so I can clearly make out my node exporter matrices are being coming, to my Prometheus. Now we have sent this data with the help of Otel collector agent. That is how I want to show in this, quick example. And yeah, that is pretty much on to this case. I've already checked the matrices. Now let's see some more, complex use cases, or you can say the other use cases which have demonstrated on this. Okay, so we have seen this example. Now let's see some more complex example where I'm sending my matrix logs and traces. This is another configuration. Now I can use Helm chart also. This is one of the values file which I am using when I'm installing the OpenTelemetry collector Helm chart. So I can install my Otel collector agent with manifest or with the help of Helm chart. So Helm chart is same. The only thing you need to understand when passing the value.yaml file, the receivers, the configuration receivers are same. I'm using Prometheus pull mechanism. Okay. And then I'm sending, now this is interesting use case. Some exporters here are three. Okay. Now I'm sending my data to Grafana cloud. How Grafana cloud? Now this OTLP is sending data to your tempo endpoint. This OTLP is sending data to your logs, and this OTLP is sending data to your Prometheus. And you can clearly see those things are explained in services pipeline. So I have three pipelines. A matrix, the exporter is going to this, and logs are going to this, and traces are going to this, and we have extensions for storing uh, the username and password. I can pass my extensions like this. This is another example of installing open telemetry collector via Helm chart. And there are a lot of other videos in the same place you can see, but this is the configuration that I can pass, right? I can send only the logs with the help of this YAML file. Okay, now how these things remain same. Since I want to collect logs, I will install my Helm chart as a daemon set, and then I will do the same thing, export this locky endpoint, and then I'll just install the pipeline containing locky. Right now, this we have seen, correct? Matrix logs. This is for your same thing which we have checked, but yeah, in this case we'll see something more. This is the getting the log. So we have extension same receivers we are sending. We're creating one receiver for the OTLP, one for open census, fluent forward for logs, Prometheus again for collect own matrices, hotel collector. This is the hotel collector own matrices, node exporter. You can pass it like this also, and then you can have any application related with matrices that you can uh, pull these. So I have a pet clinic application that I'm pulling the matrices with this endpoint. Okay, all these config files I've used in different videos in the same section. So you can see these are all different examples I want to show. Okay, so here I'm capturing the matrices, the traces. Now this is again interesting config map. So I'm saying a receiver is OTLP. Okay, Prometheus for matrices, and then host matrices also I'm collecting. And then now let's see what we are doing. So matrices, I think it should be fine. So I'm getting the matrices from OTLP, Prometheus, and host matrices, but this is the three input data sources, but I'm sending all things to Prometheus remote write. So I'm sending all my matrices to Grafana, this local Prometheus, okay? The way we have just explained. And I'm getting the data from OTLP. I'm getting the application matrices from 4317, the pet clinic application matrices. And then we have Prometheus, which is a pull mechanism for pulling the hotel collector, node exporter, and pet clinic application matrices. Again, okay, second input, and then we have host matrices, which is being collected by the hotel collector only. So three kind of matrices I'm getting, and then sending all these things to my remote right. Now for traces, it is straightforward. Traces, I have an this 4317 gRPC port. You can see the I'll post it into the description section. The pet clinic is this is a push mechanism. Pet clinic is sending all the traces to port number 4317, and then ultimately the pipeline is sending it data to Zipkin, which is the another exporter. Okay, the another data traces database, right? So this is another example of pet clinic only matrices we saw, right? Um, Again matrices. So yeah, that is pretty much. I think we have covered matrices only. We have covered matrices, logs, and traces also. We have covered logs also, and you can see all the different MD files. If you want to see matrix logs and traces, you can follow this documentation. If you want to see only matrices with on Kubernetes, you can follow this. And all these, sorry, all these MD files are used in different videos into the same OpenTelemetry playlist. You can follow along. For capturing only matrices on Kubernetes using OpenTelemetry, follow this documentation. If you want to capture only traces on Kubernetes, you can follow this documentation. Capture matrices on Ubuntu machine, you can follow this documentation. If you want to capture matrices from a Prometheus, which is having username and password, so you can follow this documentation. If you want to capture the logs from a Kubernetes using OpenTelemetry, you can follow this documentation. Yeah, this is for non-Kubernetes getting the application traces, non-Kubernetes getting the application matrices, non-Kubernetes getting the application logs. And yeah, all these documentations are used in different videos in the same OpenTelemetry playlist. The one thing which was missing was to make you understand the crux, how it works, and so on. That is what we have explained today. If you have, any questions and queries, you can put down into the uh, comment section. I'll try to help, and I'll try to resolve if I can. So this session was a bit long, but sorry. But I try to explain the open telemetry concept. I hope you liked it. If yes, please do like and subscribe and post down into the comment section if you're looking for any interesting use cases on open telemetry. I'll try to help. Last but not the least, please press the bell icon so that you can get all the questions and all the videos pertaining to open telemetry and other sections. So I want to show you quickly my YouTube channel just to see. This is the channel I'm talking about, right? So you can come down and then understand what
Hello.
what is. There are so many videos, and this is the open telemetry playlist I'm talking about. Okay, this is the playlist where we have with the open telemetry playlist. Yeah, so where we have all the use cases that I was explaining. Okay, all the use cases. So do check out this playlist. And if you have any questions, then there's a latest video on this open telemetry operator also. This is auto instrumentation. So do check out all these things, and let me know in case of any issues and queries. So maybe let's take a stop, and we'll come back with the other section, other videos on this open telemetry and something else. Till then, goodbye. Do take care of you and have a great week ahead. Okay. Thank you. Bye bye.